Good morning, everyone. A very warm welcome to all the speakers and delegates present over here for the Smart Communication for Smart Utility and Smart City Workshop at India Smart Utility Week 2023 in collaboration with DOT-TEC and TSDSI. Now we are going to start with our first session on 5G private network for utility and smart cities. I would like to invite our chair, Mr. Sushil Kumar, DDG at DOT. Our moderator, Mr. Alex Vikas, ADG at DOT. He's joined us online. Now, may I also invite our speaker, Mr. Phil Reacher. He is the president and CEO of Wisant Alliance. Phil has extensive experience in wireless communication protocol, standard, and testing. He has been an active contributor in the development of communication standard and the specification of test plan for a number of smart utility network standards, including advanced metering infrastructure and home energy management system. Mr. Sanjeev Rana, HOD Communication Technology TPDDL. Mr. Rana is an experienced smart grid professional with 17 years of deep business functional and technical domain knowledge of power distribution utility developed at a Fortune 500 energy company. Welcome to sir. Mr. Sanjeev Rana. Yeah, please sir. Please sir. Please sir. Mr. Yogendra Patwardhan, Associate Sales Director, Hitachi Energy. He has extensive experience in long-distance communication technology, mainly fiber optic communication and power line carrier communication. He joined Hitachi Energy in 1986 in Mumbai and has since held various roles in sales, marketing, and general management. Over the last 36 years, he has gained experience and contributed to the operation of customer, primarily in India, and has also served customer in the neighboring country of Nepal and Bhutan. We'll require one more chair here. Okay. So Mr. Andrew Carvalho will be joining online. He is the CEO of CNG and co-director of Cedar, Texas State University. He has over 36 years of experience in the energy, telecommunication, computer, and software industry. Then we also have Mr. Jani. He has joined us online. He is currently heading Bypass Smart Grid globally. His passion is to connect unconnected. His top skill includes sale, IoT, and smart metering. So we welcome you all. We'll be needing one chair for Yogendra sir.
In the interest of time, since each speaker will speak one by one, maybe you could, do chairs and get started.
Yeah. Okay. So
and the chair is being organized.
And yes. And
we are not able to see the whole delegation there. We are only able to see what is online.
So you'll not be able to see us, sir. I mean, you can hear us. So we'll start with Mr. Alex Vikas.
Thank you very much. Before I start, can you tell me and let me confirm the delegations who are there?
1 minute.
Okay. And
Volume is not good.
You see there? Online? Offline, I'm noting down. Are you able to hear me?
1 minute, sir.
Okay.
Yes, sir, you can go on.
I'll start from the beginning.
Yeah.
Chair Sushil Kumar sir is there. Okay. Next, Andres Carvalho. Is he there? Ankita, are you trying to speak anything? I am unable to hear.
Yes, sir, you can go on. You can start with the session, sir.
Yes, no, I'm starting the session. Before that, I just want to confirm the delegation. Okay, Sushil Kumar sir is there, Andrew Carvalho is there, Johnny from CTO Wireless. We can see each other. Yes, thank you. And then Sanjeev Rana ji has come.
Yes, sir.
Other than that, anyone else I missed?
Mr. Yogendra Patwardhan sir is there.
1 second, I am noting down. Again, there. Next.
Yeah, Mr. Jani has joined online. Then we have Mr. Sanjeev Rana.
Sanjeev Rana is done, and Johnny is done, Anders Carvalho is done, and Sushil Kumar is done. Any other else I missed?
No, that's all, sir.
That's all, right?
Yeah.
Thank you so much. Respected chair and distinguished dignitaries, welcome to the session 1, which is on 5G private networks for utilities and smart cities. I am thankful for the smart city management to give this opportunity. Before we start this session, I just want to say 2-3 lines regarding private networks. I am not going to dwell deep into what is private networks and everything because I am sure that distinguished speakers are going to throw more light regarding this. As on today, there are multiple developments happening, multiple flavors of private networks are coming, and multiple policies are framing up in different parts of the world. As on today, from the government of India perspective, just want to give a 1 minute brief that government has taken even a proactive step regarding identifying these private networks. Already, the guidelines, necessary guidelines, has been released. As on today, in collaboration with the telecom service providers, anyone can establish the private networks with 2 to 3 different models, like taking a spectrum and establishing your own network, or you can say you can ask the TSPs to establish the network, or else you can ask the OEMs to establish the network by taking the spectrum. So there are multiple flavors has been coming up. And we are sure that it is going to, it's a 5G being a cross vertical platform, it is going to affect, you can say, impact important verticals like power and also the mentioned smart cities in a very big way. Like we can see so many transmission lines coming up, which power is like a, let's say, critical sector, which needs its own SLAs and it needs its own KPIs. So we are sure that 5G is going to serve the purpose. Right now, Sujil Kumar sir, first shall I, passing on to you for a remark, sir. Then we'll start with individually, person by person, sir. Sujil sir. Yes, sir.
Yeah, thank you, Alex. Good afternoon to everyone present here, and good morning, good afternoon, and good evening to all those who are in remote. First of all, I would like to thank ISGF and TSDSI to give me an opportunity to speak my views in this conference on Smart Utility Week and this session on 5G private network for utilities and the smart cities. As we know that 5G, IoT is one of the most emerging technologies that is being used to create a smart infrastructure in various verticals, including the power sector, that is the smart metering and the smart grid, then automotive, smart remote health management, safety surveillance, and others, and all these verticals are the work as a pillar for the smart cities. Now, 5G is the communication technology, like 2G and 3G. These technologies were for voice and for small data. Then the 4G came for the broadband, real broadband services, and 5G, which was launched by Honorable PM in India Mobile Congress in October 2022. That is basically it's the technology for the vertical industries, and the main use of this technology will be for the cellular V2X, the intelligent transport system, and the private networks, and private networks for the industries or industry 4.0. They are already being built up across the globe. Even these may be built up on the telecom service provider networks, as the TSPs are already rolling out the 5G network in so many cities across the country, and what I feel in near future, at least all the cities in the country will be covered up by the 5G technology. So these private networks can be built up on the spectrum available with the telecom service providers. Moreover, the DOT has already released the policy guidelines in June 2022 for the enterprise which may have the spectrum for the private networks, and these networks may be deployed. These networks may remain isolated or may get connected with the public networks. Both type of networks can be deployed, because ultimately data is required to be transmitted to other part also. As 5G is the technology which will be having the ultra reliable, low latency, massive machine type communication, and this enhanced mobile broadband. So these features can be used in the development of the private networks. Now, the smart cities are already being built up and across the globe, and the backbone that is working on optical fiber cables. There are several various type of use cases, whether these private 5G network will be suitable for the smart cities or not. It's a question of debate. Now, this for the utilities, it will in the power sector, it will cover the generation, transmission, as well as the distribution. And in the transmission, we are having the smart grids being managed by the power grid, and the utilities, in the utilities we are having the smart metering segments, and these smart metering is being developed using various type of communication technologies, whether it is the low power wireless communication technology, or the LPWAN, or the cellular, or in future we will be having the messy type communication for connecting the smart meters. It all depends upon the use cases. Then this spectrum is available, whether in the utilities, in smart metering segment, or the smart city segment for connecting the various devices. The 5G private network will be profitable, or the return on investment will come or not. It's too early to mention this thing, but we are having various type of communication technologies as on date. But no doubt we can have a look on in generation. What I feel, the 5G private networks may be possible. It will be just like Industry 4.0. But in the case of a smart grid, which is from one end of the country to another end, whether the private networks will work or the public networks will be economical, that is also a point of debate. And in the smart metering segment, that has also to be seen. This we are having distinguished speakers on this to have a discussion. Then I will not take much time. Now I would request, I will close my points here, and I would request Alex to take the eminent speakers, and we can listen to them, how this enterprise network or private network will be maybe useful for the smart cities and the utilities, and how it may be economical. That has to be really seen. Thank you. Thank you very much.
Thank you very much, sir, for covering the entire landscape of 5G and IoTs. I'm sure that the eminent speakers also got some insights about what is the developments, policy developments, and the technological developments in India. Sir, what I will be doing is we'll be calling one by one the speakers to give their remarks. Maybe 5 minutes each we'll be giving. At the end, to summing up also, sir, we'll be requesting you for your comments, sir. Shil, sir. Okay, let me start from the first speaker. I'm going a little bit, the order which is given here. Please don't mind about the orders. First, I'm calling Andrews Carvalho from Texas State University.
Alex, any chance that you I would go first? I really need to release the space. and not go to the very loud space.
Sure. Then hope that it is fine with the first speaker. As requested by Mr. Jani, I am giving it to you. Mr. Jani, it is our to you, please.
Excellent, thank you so much. I don't know if you are able to put my screen visible there. I'm already sharing that in a Google Meet. My message here is to bring it the news on the world first non-cellular 5G. So thanks for the intro already that we discussed about that there's spectrum, which is the licensed, non-licensed spectrums.
Just a moment. Is everyone able to see it in a full screen mode? Ankita, just kindly check from your end whether the presentation is visible for everyone. I don't think it is in full screen mode. Yeah.
Let me do again.
Yeah, please.
Can you confirm now?
Yeah, now it is. Please.
Perfect. So this new technology is called DET-NR+, and my name is Jani Vehkalahti. I'm heading Smart Grids at Wirepass. Short to the introduction, I think it was good to in the intro as well, to covering that there needs to be the reliable way of communication, and this new 5G standard it's a great fit for the smart utilities and cities in the different use cases. Not for all, so there's still the narrowband communication. And this ETSI standard called DET 2020 NR is ratified by the ITUR, and it has become a part of the IMT 2020, which is better known as 5G in a common language. Quite often the people are missing that the 5G is only for cellular technologies, but actually 5G can be also non-cellular technologies. And this is exactly how this technology has been standardized. And it's a combination of the field-proven mesh protocol and then the latest, most modern cellular communication as a physical layer. Timing-wise, it's very good. This technology is now demonstrated in the NWC in Barcelona, first time in publicly, and this is available in the mass production during 2023. And I think this is very interesting for India. If you look at the timing in the rollouts, that the India can take actually the massive leap to the latest generation of the technology immediately without going all the kind of legacy technologies. Why it's part of 5G? So in the intro there was mentioning the massive machine type of communication. This is exactly the corner that the DET 2020 NR standard is fulfilling. So it's easy to deploy in a massive scale in high density applications. It can also meet in ultra reliable low latency communication in certain applications. But usually this bottom left corner is the one that is missing on the cellular technologies. What is it actually? So it's a multi-hop wireless mesh technology, which has obviously great the coverage, because every single unit that has been deployed will improve the coverage of the network. So it's self-healing, it's decentralized, so all the decision making of the network has been done locally by the device itself, which makes it that autonomous wireless network, which makes once again that it's very fast to deploy, it's easy to add the new devices with the minimum network planning, and there is no requirement for the network provisioning. So it's as easy that it would be the deploying a cellular devices on the field. And compared to the cellular, there is not a single point of failure. So there is not a single base station and they are reliable. There is not a single link. Any device of the network can actually be the access point. And this makes that it's a one network and there's a many use cases. So when you take the street lighting, for example, in the smart cities, it's easy to add the different type of sensors into the same network without any additional cost, and it can drive also the very, very low power and the long battery life applications. And then if you look like how it's been done, so just a reminder that when we talk about the 5G technology, it does not mean that you need the cellular coverage. This is how the DEC NR Plus works. So any device will improve the coverage, there is no dependency of the cellular towers or base stations. So firming an own mesh network and a private 5G network, only the device itself needs to be deployed. And this can be also run in any spectrum, which is lower than a 6 gigabytes. So it can use the ISM band, so it's like 865, 2.4 gigahertz. It can use the non-licensed band, like 1900 megahertz, or licensed band, if someone wants to allocate this use for the licensed band. So this documentation is available. I'm not kind of utilizing too much time to kind of go in the details. You can find this information from the ETSI. The key takeaways here in this slide is that the physical layer is utilizing the latest, most modern LTE-M type of hardware, which means the OFDM modulation and the HARC in the physical layer. And then in the application layer is completely free. And that is like supporting the multiple different applications, like DLMS is quite common in smart metering. In a street lighting, we see the different application protocol. So this is left open outside of the standard. The second thing is in the characteristics. So, okay, the first release of the standard will be operating in a 1.9 gigahertz frequency band because it's globally available. And then what is great thing is that there's no duty cycle limitation because it's built in a standard that there needs to be the coexistence of the devices, even though that there is a high transmit power, so up to 23 dB. And this leading to the fact that the devices can be 3 kilometers apart in a line of sight. And obviously, if there is a buildings in the between, they work as a routers because there is a new devices. Today I'm here in Barcelona. We are demonstrating together with the Nordic Semiconductor this 5G mesh as a product. So it's already available today. There is a mass production capability in hardware. This software has been already tested in other hardware. So now these kind of two things has come together. So key takeaways. It is like a smart metering, smart utility applications, smart city applications. They need to run for a long time. So it's important to rely on the future-proof technology, which this is. This is also the something that where the kind of one which is deploying those devices is totally in the control. Even that this is a new technology, it's based on the long-term field-proven implementation. So it's been proven the 99.98% SLA on the field in the very large-scale networks, over 5 million devices based on the same technology, but lower performing physical layer has been deployed in the field. This is really the best hardware that you can find out there today for the radio communication. And what is great, I mean, that we should always be happy if there is available a new unlicensed band for the smart meters and smart utility use cases. So by utilizing this standard, this is giving a new spectrum available which was not there for these use cases. And yes, it's available today. So I thank you so much for the invitation to India Smart Utility Week. I would like to be there in person. Unfortunately, this week is overlapping with the MWC. If you want to hear more, please visit our booth. Ashish Shahid is presenting us in our booth in India Smart Utility Week. Thank you so much.
Thank you very much, Mr. Johnny. Your lecture is very insightful. The non-cellular aspect you have brought in, it's a very interesting thing. DECT 2020 standards you have talked about, and even that mesh network, it's also very, an innovative thing. I will do one thing. Let me just speak. Ankita, shall we take the questions now, or shall we take the questions at the end? What would be the best option?
Yes, sir, we can start with the question. We'll be leaving, right?
Mr. Janani, they are asking me. Mr. Jani, will you be there, or
Yes.
You'll be there until the whole session?
I need to jump out 30 minutes. I'm able to listen, but so I will be up available end of the session as well.
We can take one or two questions.
Yeah, we can take one or two questions then, sir.
Okay.
Yeah, Mr. Jani, this
Yes, sir, please.
whether these specifications are the part of will be included in 3GPP or are the part of 3GPP specifications? Are you hearing to me?
I'm afraid you need to repeat the question closer to the microphone.
Yeah.
Maybe Ankita.
I'm asking whether the specification mentioned by you regarding the DEC technology, which is said to be the 5G technology, whether these specifications are the part of 3GPP specifications, because you have mentioned about the massive M2M communication in this. First thing, whether it is the part of 3GPP specifications or not. Yeah, please.
Mr. Jani, you got the question?
I only get the words here and there. So was there that, is it part of the 3GPP?
Yes. Is it part of the 3GPP? That is the query. You can answer.
No, it's not part of the 3GPP. So ITUR is the one which is owning the 5G. So this is going under the IMT 2020. That's the kind of the highest level. So IMT 2020 equals to the 5G. 3GPP is contributing the cellular standards for the ITUR, while in this case ETSI was the standardization body contributing DECT NR Plus to the ITUR, becoming a part of the IMT 2020. I hope that clarifies.
Oh, okay. Then the 5G cellular network, they are also having the massive machine-to-machine communication, and the smart meters and other devices may be connected on those features of the 5G networks. Then what extra features or facilities can be provided in this network so that the consumers take your network and not the TSP's network, which is already being deployed?
It's a super good question. I think I would bring it up the first economical. So economically, it is actually the lower cost hardware that you can implement by utilizing these OFDM OFDM HARC radios. So that's something that will happen. Second, there is no subscription fees. There is no need for kind of establish the infrastructure to run this. So that's like makes the economical part. Then if you look like the functionality, so this kind of mesh topology is allowing a higher density in the same spectrum compared that you would be using the 3GPP approach. So this has been ratified by the ITUR, and that was a result that it will allow the higher density of the devices in the same spectrum compared to 3GPP. And if you look the population on the India and the density of the cities and the use cases that are piling up, this is exactly what is required on the field.
And how much data it can transmit this from one node? Like in the case of a smart meter, how much data it can transmit this data?
I'm sorry, I couldn't hear the question.
Yeah, what is the data carrying capacity of this technology?
Throughput.
So this is depending once again on kind of what the standard is allowing and then the physical radio. So if you take a standard modem, this is one thing. Then if you look what the standard is defining today, so in the link level, it's 3.4 megabytes per second. That's the bit rate that is able to use with this new standard. So this is still the narrowband communication compared to 3GPP, but this is ideal for this kind of smart metering use cases where you need to collect a large amount of data for the tens of millions of meters at the simultaneously over the network.
Any other questions?
Any other queries, please?
Yeah, Alex, with your permission of the chair. Jani, this is Bindu Srivastava from TSTSI. We are India's telecom standards development body. And the DECT standard that you were talking about, yes, it is a very well-known ETSI standard. Do you have any implementations where a large amount of load profile data for meters, smart meters, because we're talking in context of smart grids here, a large volume of data from meters being transmitted over this technology?
Yeah, I hope that I heard it right. So you're asking that is there a large scale deployments utilizing this?
A large scale deployment or a deployment where data from meters, a large volume data from meters is getting
Yes.
getting communicated.
Yes, so this is already proven in environment where we are utilizing the spectrum where you have a duty cycle limitations and there is less performing hardware. And these scenarios, we've been proven this technology in the field. Now the same technology has been combined with the better physical layer and without duty cycle limitation thanks to this new standard. So this is already in a quantity. So biggest networks are like 1 million units in one single network. So and there's a 15-minute reading, and as you know that the DLMS, it means that you need to read the 300 bytes roughly every 15 minutes. So yes, it's already proven. But like I said, this is not designed and defined for the video streaming purposes. That's for the cellular purposes. But for the smart meter, big data, this is very good fit, not only in the paper, but really proven already in the field. But not in this combination, because this combination of the new hardware and this technology became only available today.
Thank you very much. And because it seems to be on the unlicensed spectrum, probably the registration of the devices into the network, the security and other aspects, are those taken care of in the solution stack?
Yes, so security has been already inbuilt in this standard. So it's using the industry standard like AES 128 security end to end. So both in the signaling and data load. So that has been taken care of already in the standard, but also in the implementation that is available today.
Thank you very much, Johnny.
Thank you very much.
Thank you so much.
Thank you very much. Let us go to the next speaker, Mr. Andrews Carvalho from Texas State University. Ankita?
Mr. Andrews is not here. He is not joined.
Mr. Andrews is not there?
Yes. So we can start with Mr. Phil.
Okay.
Yeah.
Shall I stand up and speak there? I have no slides.
Yeah.
Whatever you like. Okay, let me stand. So, no slides. So, thank you. Thank you, everybody, for hearing what I'm about to say. As you're probably aware, I represent YSUN Alliance. YSUN has a competing mesh technology to that offered by Wirepass that is standardized as an IEEE spec and also adopted by BIS as a BIS standard. So this is a 5G discussion, so I don't actually want to go into the differences and have a slanging match between the two. If you want to hear my reasons for thinking that the 2857 specification has advantages over Wirepass, please come and see us at our booth. What I'd like to do, though, is to highlight some of the comments that Yanni made and share the benefits of using hybrid network technology. So 5G brings a whole load of benefits in terms of improved data rates, which allow you greater node density, reduces latency, which is fantastic for a whole range of applications, particularly things like connected vehicles and autonomous vehicles, which we're going to see a lot more of. One of the things Yanni mentioned was things like meter read data. So one of the utilities that we deal with in Asia and Southeast Asia currently has a very large number of meters, tens of millions connected onto their network. They are doing 15-minute read data right now. Their next generation, they are looking at 5-minute read data. And that's for around 30 million meters. So when you're looking at traditional connectivity for that, so number one, you're never going to get a good connection to every one of your smart meters with any cellular technology. Well, if you do, it's going to cost so much money in terms of providing base stations to do so. So therefore, you need some sort of mesh networking connectivity with some data aggregation point. So a DCU, wireless mesh works particularly well. One of the advantages of using 5G is that you can actually now achieve a much faster connection onto the backhaul. So typically with a mesh technology, you are going to maybe have 500 to 1,000 meters connected to each DCU up to, and then that will connect through LTE or fiber. With 5G, you will be able to get much faster meter read data with a similar density, or even enable a whole load of new applications by providing lower data concentrations. So we're now looking at a whole new scenario where we're not only looking at meter reading data, but we're enabling scenarios where it makes it much easier to take data from a smart meter, some of the ancillary data, such as voltage, phase angle, etc., and use that into the distribution network and control volt var management. So there's a range of applications. One of the other criticisms I might have of 5G technology, so 5G technology is great, don't get me wrong. High speed, great for low latency applications, but we're looking at not just electric meters, but we're looking at water and gas meters, which require 10-year battery life. As Yanni also mentioned, the cost of the silicon needs to be reasonable price. So therefore, for very low cost sensor type devices, which require a long battery life, for utility, that's water and gas meters, but in a smart city environment, you could be talking about solar parking meters. You could also be talking about air quality monitoring, which could be solar or primary cell powered. Then I would say, it's an overkill to include a 5G SIM in every one of those devices. So, in short, great benefits from 5G. Its use really comes to benefit when you're looking at hybrid networks with 5G as the connectivity to the backhaul, and then another comparable wireless technology for connecting low-cost, low-power sensors onto the same network. So, thank you.
Yeah, am I audible? Yeah. So thanks, Alex, Ankita. Thanks, Sushil sir. And I would like to thank ISGF for providing this platform to share the utilities views, utilities expectations on 5G and private networks, and other utility specific requirements from the communication. Okay. So if you see, these are the different layers of distribution. If you see, if you start from the first layer is asset and infrastructure, where we have the transmission line, distribution substations, then we have operational hubs, customer premises, and now this DER. Next layer of devices is control and instrumentation. That is the devices and sensors, whether it is auto reclosures, HPIs, RTU, FRTU, smart meters, and all that. So next layer is the communication system. and over the top of that is the applications. When we talk about the applications, it's all about real-time power management and control. So in the entire ecosystem or in the entire value chain of distribution, like all the devices or all the layers, all the devices should be intelligent. They should be like interconnected, and they should be remotely controlled. So when we call this the value chain as smart value chain, then all the devices are intelligent, interconnected, and they can be remotely controlled. Then we have certain applications like SCADA, distribution automation, outage management system, field force automation system, real-time power management, which sits over the top of these layers. So here, when we call it smart, we need to digitize everything. That is all the equipment, systems, and processes to make it like there are three stages like digitization, digitalization, and digital transformation. So to make it smart, we'll need to start with the digitization of all equipment, system, and processes. Next is these are the different applications. These are the different applications. These are the operational applications, IT applications, commercial applications, and the consumer-facing applications. Now, if you see the list of these applications, all the applications are having different attributes. When we say about attributes, it's all about the latency requirements, bandwidth requirements, then priority of those applications. Like if you are as a utility, if you are required to run 2021 different applications over the same network or different networks, then you need to prioritize those applications. So the different attributes are latency, bandwidth, priority, and the number of devices. Okay, so there are certain applications like you can see the variation. Like if you see the latency requirement in line differential relay protection is very low. It's less than 15 millisecond round trip time. At the same time, if you see the bandwidth requirement of the ISS system, the integrated security solutions or GIS system, there we need a very high bandwidth. Okay, so there is a huge variation in the requirement of different applications. Okay, so what are the driving forces for these utilities is utility must have certain capabilities. A smart utility must have certain capabilities. Like one is the foremost requirement is self-healing. If all the equipments, if the entire ecosystem is intelligent, interconnected, and they can be remotely controlled through SCADA, then we can actually find out which transformer is getting overloaded, which feeder, which tie line is getting overloaded, how we can switch the shift the load from one tie line to other tie line, one transformer. So that is self-healing. Another is the predictability and affordability. Like whatever we are supplying, it should be affordable to the consumers. Then there is a challenge of this renewable generation integration and storage management. Another is the utility suffer from one challenge, that is flattening of load curve. Because of there is peak demand, off-peak demand, and peak demand, so the engineers, they are mostly they have this challenge of flattening this so that the variation in demand and supply gap can be minimized. And the utilities are having challenges of stringent regulatory compliances. That is always there is a pressure of overdraw, underdraw, then there is a frequencies. So for the utilities to operate in a very smart manner, they should have a very strong communication system. Like if you see the smart grid system, then you can say the communication is the nervous system, and I will personally call it that communication and the GIS, they are the foundation technology for any utility to be smart. Okay, so the communication system should be designed in a way that it should be secure. That is the first requirement. It should be scalable, reliable, and resilient. Okay, being in power utility, like when do we need communication? We need communication when there is no power. Okay, so the first requirement is communication should be present when there is no power. Okay, now what is 5G as an enabler for a digital transformation of utilities. Like I said, the first stage is digitization, then digitalization, and then now it is digital transformation of utilities. That is, when we say digital transformation, that is enablement or introducing new technologies to fundamentally change the business, how we operate it, how we deliver values to the customers. Okay. Now, if you see the distribution utilities, now they are graduating from the traditional hard base to distributed generation, transmission, distribution, and software defined industry. Okay, it's not like a traditional hardware defined industry. Okay, so now there are new applications which are coming up, which have been deployed actually. Some of them are this artificial intelligence, machine learning, device to device communication, machine to machine communication, digital twins, data analytics and control. So these different technologies are required for to meet these requirements from the utilities. Okay. So another is the requirement of private LTE or 5G networks. Like why we need a private network? See, from the distribution point of view, the communication is not our area of business. We are experts in distributing power, not in communication system. But I have studied more than 146 utilities across the globe, and out of those 146, maximum utilities are having their own private WAN network. Either it is on SDS technology or either it is on IPM-PLS technology. So utilities are having their own private WAN network. Okay, and there are 13-14 utilities which are now migrating or which are either in the POC stage or they have deployed this private LTE networks for the last mile connectivity also. Okay. So why utilities are going? One is the by design, because we own the infrastructure. So it is very easy for us to lay optical fiber. When we are laying power cables or we are using transmission line, we can use OPGW. So it's by design we can create, at least we can connect our those locations through fiber. Second is there is a challenge when we are using the public networks, because no public network gives the guaranteed performance, guaranteed availability. So it is always best effort basis. Okay, but in utilities, like we run mission critical applications, we cannot, like if there is a line differential communication to be established between 2 points, we cannot afford to have a loose coupling. That is, the circuit should be very deterministic in nature. Okay, and then another is what utility want. If we are using a telecom service provider network, then there is always a challenge of transparency. Like in SLA I define my latency from this point to this point should be this, and it's I cannot control it. It is up to the telecom service provider. So there is a requirement from the utilities, because we need customized, because there are 21 different applications which are running at the same time. Each application require different latency and bandwidth, so they need to be customized. The network need to be customized. The applications, the data need to be prioritized. So it is always better to have a private network. We in Tata Power, we are carrying out different pilots with on 5G. We are in discussion with Nokia Networks. We are in discussion with Airtel, Reliance Jio, and in fact we had a discussion with Wirepulse also. So we are in the process of developing a 5G network in our technology center. So this slide is from Nokia, but I found this slide very relevant. So basically it defines the 3 dimensions of the value creation of IR0 4.0. That is safety, productivity and efficiency, and how 5G can play a role. There are different technology. If you call about the human augmentation, then there are teleprotection, AR, VR, and the pain areas or the focus areas of utilities is the safety, the safety of the equipments, the safety of the people who are working there. So if I can enable them with the technology which can ensure the safety, like if I will not take much time actually. If a person is standing on a ladder, he is having some technology to tell him, boss, you are putting more weight on this side of the ladder, you are putting less weight, you are how far from this live line. So these everything will be enabled through technology. So that is one of the use cases of 5G which I see. Then AR, VR is there, digital twins are there. Then another, see, everybody knows about the capabilities of the 5G. So whether it is latency, whether it is the bandwidth, whether it is the number of devices. So all the upcoming technology which are required for the digital transformation of utilities, they are being supported by 5G. On the right side there is a beautiful graph, like it is if you see on the latency part, it is varying from the 100 microsecond to 10 seconds. That is the latency required by different applications in the distribution. At the same time, the bandwidth requirement varies from 10 kbps to 10 gbps. So 5G, see, other technologies, either you have to have the fiber or you have to have the technology like 5G. Okay, so otherwise it is not able to sustain these applications. This is one example, like I want to share with you how we have designed, we have taken over the Tata Odisha distribution in Odisha. So we have designed integrated communication network for all the states of the Odisha. So there are 4 distribution utilities, and there we are using this. Basically, why I am discussing this is because from the smart city perspective. Okay, if you want to make the city smart, then you will have to make the utilities smart, whether it is electric utility, gas, water, transportation. So these networks we have built using the state networks, also using the PGCL or other. We are building. Actually, we have not built. We are designing this network. So this I want to share with you. Only challenge with us is being, again I am repeating, we are from distribution. Communication is not our forte. So maintaining these optical fiber, laying these optical fiber, because these are very capex intensive projects. So laying fiber at each and every corner is not economical. So maybe for the super core or the core network, we can use the fibers on lease or bandwidth on lease, or we can own the fiber. But for the last mile connectivity within the cities, you need to have a communication system, because see, in Delhi, we are having a network of 400 kilometer of optical fiber. Every day, I do take care of the operations. So every day I am facing 3 to 4 breakdowns by different agencies. So if you are covering a states like Odisha, you cannot, how many teams you will put? So it becomes difficult for utility to lay optical fiber, maintain optical fiber network. But at the same time, you need to have a technology which is at par with the bandwidth on latency and bandwidth. So 5G fits on that. Okay. These are this slide is, I just want to cover only from the just to share what we have done in the smart metering. In smart metering from the Tata Power point of view, we are, I think, 4 lakh plus smart meters we have deployed. They are on different technologies. We have deployed this RF mesh technology, then we have deployed this NB-IoT technology. Now we are 4G technology. We have meters on the 4G technology. Then we have meters on the hybrid PLC. PLC, we have not deployed anything, but we are evaluating it. Okay, so what is happening is, on the communication side, we are really struggling. One time we are going with 4G, we are going with the NB-IoT. We are testing the technologies. So in the what is happening, because interoperability is required. We have created interoperability on the head-end system side, on the MDM side, but on the communication side we are still challenging. We are still struggling. Okay, and this side is right side slide is on the ADMS system, where we have this. I just want to share how the different systems, different applications, they are being integrated. They are required to transfer data on the real-time basis. So this field crew is there, then you have field force automation, then your SCADA system, which is then again connected with the GIS system, power manager systems, and different field devices. So and this is the dashboard. These are the real-time dashboards. On the left side, that circle shows how many meters are offline, how many meters are offline. Like if you are having millions of meters, so you need to have some kind of dashboards. On the right side, this is a SCADA dashboard which shows how many consumers are out of power, what is the frequency going on, what is the overall, under all those parameters. Okay. So this is my last slide. So what my submission to the chair also, Sushil sir also, we have applied for this CNPN license, that is captive non-public private network. So it is still under consideration, but only thing is, like if we, like in other utilities, like in Europe and US, utilities are having these licenses. Okay. Only challenge with us is being in transmission and distribution. If it is within the enclosed boundaries, then utilities will not be able to use it. Another is private 5Gs. Like in Europe, utilities, they are having collaboration with the telecom service providers, and even and two utilities I have read that they have been assigned certain license by the government. So if such, because that is the requirement of the utilities. If we really want utilities to be smart, then you need to have that kind of, and we are just evaluating this, if we can create our private 5G. There are 2-3 models, that is the private LTE, how Poland has done. So the same way we can have this private 5G network where we have either in the dedicated or in the hybrid model. Only thing is the telecom service provider, they take it as a opportunity to earn revenue. Utility take it as a opportunity to serve customers, to make themselves smart. So that is a challenge which is going on. Then there must be some, I have not spoken on the technology and standardization. Actually, Bindu ma'am must be like thinking about it. But yes, there should be some recommendations on the last mile communication protocols. Like there are multiple technologies most of the technologies, they have been implemented in silos. Then you design point-to-point integration and all that. So maintaining so many systems, maintaining so many technologies, having so many experts for different technology, it's really a challenge. So there should some recommendations on last mile communication technology. At the same time, there should be some, as IoT is coming up, then on the scalability and performance, like what are the protocols we use, then on the data storage and information model, then because different applications needs now everything is migrating from on-prem to cloud. On one application we are using this cloud, on other application we are using that cloud. So there should be some kind of standardization and interoperability between them. So that is all from my side. Thank you. Thank you. Thank you.
Thank you so much, sir.
It's okay? Yeah. Okay, let's start. We have seen many perspectives about 5G up till now. Most of them come from smart cities. Most of them come from how you can make an entire city 5G enabled and things like that. I'm going to talk more on the utility perspective and how a utility telecom vendor looks at 5G and its approach. Okay. So we have shown three systems here. One is the age-old power line carrier communication system, which was used by power utilities for long-distance communication. Then we have fiber optic systems, and now for the distribution companies, we have the wireless systems. Wireless systems could be 3G, 4G, or now 5G. So that is how we look at it. Generally, the requirements of power utilities are in terms of voice, in terms of data, and in terms of the protection signal. So protection signaling, as rightly Mr. Sanjeev Rana mentioned, it could be either distance protection or it could be differential protection. So the system what they are taking should be capable of all these functionalities. Now, let us look at what has happened in the history, where we are today, and what is likely to happen in future. Okay. So, in history, if we look at it, in India, communication started somewhere around 1960s or so, okay, probably even before my birth, and this was basically the power line carrier. So, and power line carrier over years, it has evolved in terms of technology. We had vacuum tube versions, we had transistorized versions, we had IC versions, we had microprocessor-based versions. Now we have DSPs. So technology has changed, but final frequency going online concept has remained the same all throughout. Even today, when we have digital power line carrier, finally it is a frequency. What has happened from, I would say, somewhere around 90s or so, I think that was the first time Tata Power gave us the order for fiber optic communication. So that is where the OPGW concept came. People started embedding fibers into the ground wire, and that started picking up from 90s onwards. So 90s onwards, if you see, it has been advent of fiber optics which has been going on. And if you see fiber optics also, initially it was pure hardware-based multiplexers. Later on, we moved to PDH technology, we moved to SDH technology. Now, all the utilities are slowly thinking of migrating from SDH to MPLS-TP. So, over a period of time, this will also happen. Okay, so we have products which are basically hybrid versions, which can allow you to do SDH as well as MPLS-TP both at the same time. And that is how we help power utilities to do this migration in a successful manner. Now, these two technologies, that is power line carrier and fiber optics, are mainly, I would say, long distance transmission technology. The wireless part is mainly played by the distribution companies, and distribution companies have been using either fiber optic cables or the wireless in a very successful way for last so many years. And if you look at it, today also many specifications in India, they talk of 3G, they talk of 4G. Now, the latest specifications, what we are seeing, they are saying 5G back 4G, something like that. So that is how it is changing. And therefore, if you look at it, we have broadband routers, which are basically hybrid devices. So you can have mesh and you can have cellular both together. So what happens is, there could be areas where cellular reach is not there. So what happens is, the same device can act as a mesh to reach the connecting point, and then over cellular, it can take the signal further up to the station. Once it reaches the station, over fiber, utility can take it to any place wherever they like. These are all the kind of systems what Hitachi Energy has with them. So we have basically the fiber optics. We have shown the TRO 600 series, which is hybrid wireless solutions. And this is our solution basically for 5G. So this is what is available today, and we can give it in the market. So we are talking to different customers right now, but again, specifically for power. So we are talking to utilities. We are talking with various vendors like Jio, who can create use cases along with these devices, wherein that becomes a stepping stone for the utilities to see the use case and then see how it can be particularly used. These are all the products what we have. I think that's all from my side. Any questions? Welcome.
Good evening. I'm Nitin Marjara from Tata Power. I'm head AMI and I'm implementing smart metering in Odisha. I've been part of the team of smart meter implementation in Delhi as well. So worked in RF and cellular as well. Now, the question is, since we are already implementing smart meters with 4G technology across the country and nothing less than 25 to 30 lakh meters are already in circuit. So moving over to 5G means another leap of technology, and these meters are very cost. If these are quite capex intensive. So if we move to 5G, and how we are going to handle the meters which are already in 4G? Are we going to live with 4G with 5G over the network available? So and the way the technology is moving on, by the time we'll be completing this project, 5G will be deployed and will be ready with 6G. So it's becoming always difficult to cope up with the technology, whereas the metering industry is not moving that fast in terms of adopting it. Second thing, standardization in terms of NIC cards is not there. If I talk of mechanical fitment or the pin configurations even a single manufacturer is not able to switch their meter from one technology to the other technology. So it's becoming very difficult for the utility people to switch over to these technologies by themselves. So how to handle this part?
Yeah, let me reply from, I'm from the government as well as from telecom background. You see, in India, almost all the telecom service providers, they are implementing the 5G non-standalone mode. Means they are upgrading the 4G network to 5G. So 4G will continue to work. These are not the standalone mode. These are in non-standalone mode. They are developing it. And moreover, the cellular technologies, they are based on 3GPP specifications, which are backward compatible. Suppose you are having this your mobile connection and you are having 4G and you are going into in the area where 4G is not available. So like you can that can switch over to the suppose in the rural area 2G is working, so it will switch over to 2G. You will get the connectivity. Second point you asked. Only the 3G technology that has been closed by some of the telecom service providers. In BSNL it is working, but 2G will continue to work. One more thing I will advise that you are having one technology and then you are having the fallback options in the smart meter, the tenders which were coming. And ESL is floating these tenders for the discoms. Around 2 years back when they were having the main 2G and then fall back on 3G, then 3G, when they found 3G has been closed by Vodafone and Airtel. Then what I feel, the embedded SIM is the best option. Instead of the normal, this plastic SIM, you can ask the your device vendors who are developing the communication chips to have the embedded SIM in that, and you can then you can change the technology in that. But only the this transmission portion that should be capable of transmitting those frequencies, not more than that. So 4G will in the 5G services you need not to do anything. Now embedded SIM will serve the purpose. I would advise that you people should use the technology which are long lasting. Suppose in the discom what happens, they float the tender for 5 years or 7 years. Then suppose 1 million tender, 1 million meters have been made smart. And the technology which has come, you don't have the ecosystem in the country. Then suppose that company has closed the shop after 5 years. Then what will happen? So projects should be economical, viable, and long lasting. Whether the ecosystem in the country is available or not, and it should be based on standards. If a non-standard solution, it will be a big problem. No doubt after coming the private 5G networks, You may have the private 5G networks also, you may have the public 5G networks also, and even the telecom service provider, where they will also be implementing the private 5G networks in various industries. So in such cases, it will be easier to maintain the networks. Otherwise, if the device ecosystem, that is very important, is not available in the country, and after 3 years or 4 years, those devices are not being supported, then if suppose 10% of the meters goes faulty, then those are required to be replaced. One more thing I had advised to BIS that this in the specification IS 16444 or others, they should give the flexibility that the this communication module that should be on push-pull type. Suppose it has gone faulty, it should be replaced with the another communication module, because the meters will be for a lifetime of 10 to 12 years, and for the entire period of this meter's life, the communication module should also work. And the normal SIM will not work in that way. Like in the tracking device, if you see AIS 140, they mandated the embedded SIM in the device. It can sustain to 2 MC or 3 MC. So it all depends upon how much the cost is or the return on investment. Thank you. Yeah, please.
Thank you. Actually, we got the opportunity to talk to you. What are government policies for utilities on the private 5G or the CNPN licensing? Yesterday, there was some news that for pilot basis, some frequencies are being allotted to the utilities and private players. And last 1 year back, we have applied for this CNPN license. So, are there any policies on 5G and CNPN?
Yeah. Hello. It's working. Actually, DOT released the guidelines in June 2022, and after that, no guidelines have come. Today, before coming to this conference, I confirmed with the concerned officer, my colleague in DOT, whether some work has been done on this. So he mentioned the guidelines have already been released. Even somebody applies, then they will take necessary action on that. You may discuss, Mr. Singhal, as you mentioned that you have not got the license for that.
No, sir. Actually, we were in discussion with Alex also. Alex was the point.
Yeah, Alex can help. Mr. Alex, you can speak to Mr. Singhal, DDGAS. But after the guidelines, no more guidelines have come. That is the final one. Yeah.
Any more questions?
You want mic from here?
Just a follow on Nitin's question and on the plug and play piece. From this session, what I'm hearing is the mesh technologies and certain last mile technologies. There are so many new technologies that are coming up, and so many, starting from PLC, DLC, mesh, etc., narrowband IoT, so many have been tried. So, is there some work happening on kind of modularizing the comms piece at the meter end? So that, for example, if right now the meter and the modem, the communication piece are physically integrated, if I remember correctly. Now, if we make this interoperable at this piece, the communication piece can become a plug and play into the meter, so that at the last mile, if it is SIM-based, solution does not work, then maybe a mesh or some other plug and play module can be embedded. Just quickly embedded onto the meter. I think that will help solve the issue. The meter remains separate, and as technologies evolve or as the performance changes in that particular location, you can simply replace the comms piece, almost like rip and replace.
As far as this plug and play type of module is there, it's already implemented across the country. It's there. So any module going faulty can be replaced. Now the concern is if it has to be replaced, it is replaced with the same technology. If it's like a 4G enabled meter, it has to go back with the 4G. Only thing is we can replace the SIM card, and the new SIM card can be of any new telecom service provider. That's the only enablement. Second thing is, like sir has told, embedded SIM cards. So commercially embedded SIM cards are not easily available.
See, even the Tata Communication is working on this segment. In connected vehicles, they provided services in Kerala as well as so many other states with this CDEC.
Right.
And, yeah.
Right. So as we are talking to meter OEMs, scale like we want supplies of like 2 lakh, 3 lakh, 5 lakh meters with embedded SIMs. So probably they're not coming up with the solutions with embedded SIMs. Their developments have not reached to that level where they are using this embedded SIMs. So we are still dependent upon the SIM cards, conventional SIM cards, M2M SIM cards given by the communication providers, and we are working with those only. Second thing is, if you want to switch from say cellular to say PLC or to RF, then they have different type of communication modules for all type of different communications. You simply cannot plug out and plug in a new technology SIM cards in India. Some projects have been done, but that commercially feasibility of such type of enablements is still not there. In BIS, I was also member of ETD 13 3 years back. So we were asking about those to make it a standard for the pin configuration. But since most of the OEMs have already developed their products, they were all struggling to make their product as the standard product. Otherwise, it was again a development cost for all of them, which was increasing the cost of the product.
Nitin, yeah, it is more about the meter manufacturer being smart. They should create smart meters. Because see, what is happening now, the data modeling is different for 4G meter and VI8 meter and everything. So it's not only about the pin configuration, there are so many challenges. So,
right.
Yeah.
I can add one thing. Hello, I'm Vijender Malik from Lattice and Gear Limited. So we have worked closely with Tata Power. So what I think Nitin is saying is it's a real problem for meter manufacturers as well. You know, everything you have to see in totality with commercial angle also. It's not a rocket science to provide, you know, a cellular and PLC plus this RF into 1 meter. There are countries like Indonesia. We are working for one of the project there where they want all three technology, but that's the cost. Means so it's a only angle of cost. Technology is open to all. Means meter can develop all interoperable protocols plus all three technology into one modem. So
for how many years you got the contract for
no, we have not got
installing and maintaining those meters? In some of the countries, they give the contract of 20 years.
Yeah.
Then it will be sustainable. In India, the discoms, they after every 2 years, they are floating the tender.
No, I agree, sir. And
sustainable.
Yeah. But that's the real challenge for OEMs.
So just picking up on what former speakers have said, I think there are two or three issues. One is the lifetime of the particular technology, and certainly in the US, there were some AMR deployments relying on 2G. The public network providers decided to pull 2G. So there were a whole load of stranded meters that were no longer working. So therefore, that was one of the incentives for US to start looking at RF mesh networks that they owned, that they run privately. The US is also looking at private LTE now, probably for the same reasons, that not only do they manage their own quality of service, but they can manage the lifetime of their networks by doing that. So that's number one. In answer to your question, silicon providers are constantly improving the level of integration of devices. There was announced last November a silicon provider who was offering NB-IoT on the same chip as wireless mesh technology. And also picking up on this, I think here is one of the great benefits of standards. So India, through BIS, has said there is a standard for using wireless mesh in the sub-gigahertz band, and it specifies the modulation characteristics, the channelization, everything to do with that, which makes it easier for companies like Landis & Gear to put a comms module for that because you only have one chip, and it makes easier for the silicon vendors to develop a chip that is applicable for the India market. And sorry, one more thing. There are silicon vendors that are also, interestingly, you know, I'm here from Wi-Sun Alliance, but the G3 RF mesh, which is effectively competing, uses the same RF standard. So that makes life easier for vendors.
Thank you, Phil. My question originally was, can we remove the comms piece from inside the meter, put it in a different a physical form factor, which can get kind of plug into the, plug into the meter, almost like an RS-232 link. But anyway, I would not want to hog the conversation.
It's already there. It's already there, no? Yeah.
Okay. I just wanted to mention that.
But it costs money because
Yes,
it's
it
one
would.
more connector.
Yes, it would cost money, but considering the large rollout that we are having in India, maybe it's worth considering. Especially like what you mentioned, Landis and Gary, you're mentioning that you're trying to integrate 3 comms technologies inside a meter. You know, possibly if we just keep the meter as meter and the comms module, what we used to call the modem. I've been out of the sector for some time. A comms piece which physically integrates with a meter. Maybe the comms piece could be a could be a PLC or an RF mesh or whatever. I just wanted to mention that.
Generally, meters are agnostic to these things because
yes.
nowadays, DLMS protocol is
yes. So that's a standard. Yes.
Which can interface with any of the technologies.
Yes. So the comms piece is simply a piece of a device which is allowing connectivity. Rest the meter takes care. The meter remains smart. So that is one. And maybe if Alex is there, would you like to talk about the 5G use case labs initiative, where probably some of these experiments can happen, and then those could feed into standardizing the comms piece at the meter comms segment, which could come into TSTSI. Alex, if you're there and you would like to talk about the 5G use case labs.
Mr. Alex, are you there?
Can I ask one question?
Yes, sir. I don't think he's there.
Okay. So my basic question is like, we are talking about smart utility. Why are we only speaking about smart meters? Why not other utilities? Like water is also very important, So some of these utility meters are battery powered. They are not line powered. So how is that going to work in a 5G network? Because the 5G networks are power hungry, so the batteries don't last, right? If they have to talk.
Let me reply. So many technologies, the power is taken by the communication technology only, and there are like NB-IoT and the LoRaWAN, and in RF mesh also the power consumption is very, very low. And even so many work is in progress, R&D and others, these devices, they work for a long time. And even the sensors which are placed in the forest, nobody is going to recharge them. So either the solar or some vibration or from something, those things should get recharged. Nobody has stopped to make the water segment or the gas segment to not to be smart. Even the IGL has, I think some smart meters have been placed by IGL in Delhi. Even the water meters in Pune and other cities, they have also been made smart. It all depends how much money has to be spent on the particular vertical. Main cost is the meters, and the communication portion, that is very, very cheap. Communication is cheaper than peanuts today. So even I think the utilities can take the benefit of the communication technologies which are developing like anything. And this NB-IoT, the power consumption will be very, very less in that case. And most of the devices, they are battery operated devices. So in the battery operated devices, the power consumption will be so much less that its life will be quite high. And even it is expected that even for 3 to 4 years it should work. like for the unmanned locations. Yeah, thank you.
We also have to start the second session.
Yeah.
So thank you so much for sharing your insightful knowledge. Now may I request our chair, Mr. Sushil Kumar, to please hand over the token of appreciation to our speakers. So first, Mr. Phil. Mr. Sanjeev Rana. Mr. Yogendra.
After a long time.
Thank you so much, sir. Thank you.
Let's have a seat.
Sure. Yeah, we can.
Enabling digital technologies for smart utilities and smart cities. I'll just give a brief introduction context of this particular session. In the previous session, we've learned about some technologies, especially in the mesh segment in the last mile for smart metering. We've also learned about from Tata Power on their initiatives on enterprise-wide communication technologies. In this particular, as a follow-on to the discussions that have been held in the previous session, we will now talk about some standardization activities happening in India and globally. We will be covering, basically we will be covering some studies that have been conducted in India on communication technologies for the energy sector, not going beyond the DLMS protocol and the conventional communication technologies that we've been talking about. We will also talk about some emerging opportunities thanks to 5G, and we will be touching upon cloud interoperability and portability. So this session will also be chaired by Mr. Sushil Kumar ji. May I invite Sushil ji to the dais, please? May I also invite Mr. Rajesh Kapoor, the technical consultant from TSPSI is joining online. It's taking him a while. And Mr. Bhargav Thakkar, head new product development smart utilities from Vodafone Idea is also joining online. It's taking him some time to connect. We have Mr. Professor Brajesh Lal from IIT Delhi in the room. May I invite him to the dais, please? He will be talking about 5G enabling technologies. And we have Mr. Dharmender Singh from ESTS. ESTS has been working pioneering cloud-based solutions for the smart grids and smart cities in India. So thank you, Dharmender, for joining us on the dais. ये ठीक है Since we are running late for connecting the online speakers, may I request Sushil ji to please invite the speakers on the dais to start with the presentations to save on time. Maybe Professor Brijesh Lal first.
There is a very thin participation, and this smart communication for the utilities, no doubt everybody knows about the communication technologies, whether it is RF or cellular or LPWAN technologies, or now the 5G technologies are there, and it all depends upon the how much money can be spent by the DISCOM for installing the smart meters, and the communication part will be very, very less. Now, the security is one of the biggest challenge in in utilities as well as in the connected scenario, and there are so many vulnerabilities and hacking incidences happening across the globe, and now it is very much required that we can prevent the vulnerabilities and the hackings of the connected devices, including the smart meters or the when smart meters, transformers, or anything. If our mobile is vulnerable, it can create vulnerabilities in the meters or any of the connected devices with the internet. So, without taking much time, I would request Dr. Lal, who is the professor in IIT Delhi, and he may give his opinion about the smart communication and the security of this domain. Over to you.
Thank you very much. Am I audible? Working, right? Hello, yeah. So, thank you so much for the kind introduction. Today we're going to talk about one particular enabling technology. There are multiple with 5G, and just as we heard in the previous session, not all of it is understood fully, and therefore there are some degrees of confusion that are happening. This session will probably add a little more in terms of opportunities and therefore a bit of confusion as to which technology to exploit for what applications. The one particular enabling technology that I'm going to talk about in this session is the edge computing capability. So, as you will see, there is this opportunity and there is this need that has arisen because of a multiple number of applications and use cases where you require a large amount of data to be consumed at the edge, and more importantly, processed and used for inferencing at the edge itself. This is for a lot of low latency applications that will be required in a smart city scenario. Can we move to the first slide, please? Yeah, so this is how this particular presentation is structured, but I largely want to focus on 2 or 3 aspects. One thing that I will want to talk about is why does one need edge? The second thing that we will talk about is how is edge implemented, and thirdly, how does implementing edge enable some of the use cases that we're talking about. So, but under these headings, I will talk about a few things. So, can we move to the next slide? So, before I get into the introduction and talk about how the mobile technology has been evolving over the last 40 odd years, while we talk about a smart city, there are 2 kinds of very broad use cases that surface. One is a need for large concurrent number of connections. You want lots and lots of endpoints to be connected to a central server via hierarchies of networks, but eventually you want, for example, hundreds of thousands or maybe millions of smart meters to be sending information back to the DISCOM so that they can make decisions and probably bill and whatever else that they need to do. And the other thing that is required is immediate support. For example, when you talk of applications of the kind vehicle, autonomous traffic, or autonomous vehicles moving in intelligent transportation systems, you require low latency capabilities to be available. Otherwise, you will not be able to implement that capability. So this talk is largely about the second type of applications where the requirement is for low latency. These kind of applications also lead to two other implicit benefits. One is they help you preserve privacy because your information, or at least most of it, does not now need to go to the central server. A lot of it will be consumed at the edge itself. Only the very necessary and probably the not so private information can be sent to the cloud for a more informed inference. The second thing that happens is it also enables a layer of security besides providing low latency. So with that background, let me just tell you how things have evolved. It all started with 1G. 1G was the first technology that enabled you to connect while you were on the move, and those are largely voice services, analog. 2G moved to digital, but it was still providing largely voice services. With 3G, for the first time, we realized the importance of sending data over a communication network. So 3G did not take off as well as it would, and now it's probably not all that popular and is sort of on the way out in some markets. But it did tell us that what was the actual requirement of people using networks, and that was primarily data. So with that, we had 4G, which was largely data driven. As a matter of fact, you started having voice calls over IP. So VoLTE, so voice was given free, and all the other data pipe was charged for. And while this improvement was happening and people were moving from analog to digital and from simply speech to data, and then sending voice over the IP pipe, along came 5G, and 5G realized the potential of what communication networks could do. And primarily, for the first time, people started looking at performance measures, which were driven based on what applications they might want to service. Three categories were sort of decided. So that triangle that you might have seen reasonably often as far as 5G goes, where people talk of enhanced mobile broadband. So you wanted better connectivity on your mobile handset, but there were also two other vertices of that triangle. The other two were massive machine type communication, where you wanted large number of concurrent connections for IoT, smart factory kind of applications, and then you had the vertex which handled URLLC, which was ultra reliable low latency communication, where you would want to be able to perform low latency critical applications such as remote surgery. It might take a little while before it starts happening, but yes, it is something that we are slowly moving towards. The possibility of intelligent traffic or transport systems where a lot of vehicles are autonomous is also can become a reality based on what 5G is to offer. So as we move from 5G to 6G, as somebody mentioned, more such changes will happen, and 6G will see a lot more autonomy as far as consuming critical activities data is concerned. So edge computing is largely, it is not necessarily only for such critical applications, but it's largely a tool to enable such kinds of applications. So in a smart city, if you want health facilities to go to different places, and you have smaller hospital, probably I don't know what the term for them is, but they could have a small place that they get and put up some devices, equipment, and a communication capability, and it could be a remote center for providing medical services, or it could help in providing better traffic management. It could help providing better driver assistance in countries like India. It could also help in applications such as ATM kiosk management, where you at times might require to take urgent and quick decisions vis-a-vis incorrect usage or fraud, where people use somebody else's ATM or debit cards to withdraw money. So such kind of applications can be very well managed if one has access to edge kind of technologies. Can we move to the next slide, please? Right, so here there's much talk about the increased bandwidth, but for possibly streaming activities, 4G is fast enough. Why do we want more? To me, this was a given. The amount of bandwidth had to increase, but what's more important and what I find more fascinating about 5G is the fact that now it looks at communication as an enabler and not just as a technology. So if it is an enabler for an application which is low latency, then the network better support that capability by whatever mechanism that it seems fit. The other big change that happened with 5G, and this is not necessarily because of how the technology is that the reliance on hardware was done away with. Now with the reliance on hardware becoming lesser and lesser, what had happened is that a lot more organizations which are primarily software enterprises, they can contribute to 5G, and this has made the ecosystem quite rich and has provided India with an opportunity to make significant contributions in this area. That's slightly different. What is also important is that there's talk of next gen experiences in terms of Meta, which took off. It is going through a lull, but it will certainly come back. So people are looking to experience life more immersively, if you will. So what people want is to feel or experience communicating with the other person. It's not just about being able to hear the other person speak clearly, lucidly. It's also about being able to see the person and at times also feel the person. I'll talk about haptics in the latter half of this particular talk, and there you'll see that moving forward there's this huge thrust on tactile applications where you not only hear and see the person you're talking to, but you can actually feel a person. So you walk into a room and you can actually shake hands with the person without either of you being in close proximity of each other. Now this greatly enhances the immersiveness of the experience. This is extremely useful in the gaming field, where haptics to a small extent in the form of vibrations and some limited feedback has already found its way. Now these kind of technologies, when they are used in conjunction with the headset kind of technologies, possibilities of providing very, very high levels of immersive experiences result. And in a smart city where you want to make sure that people don't have to travel too much, you do not construct and unnecessarily, you end up with a scenario where you could train 40 or 50 people on let's say working on car engines without actually having to put up a training or a laboratory where you have those engines in place. All of these people could stay at their home, put on these headsets, put on these haptic devices, and have the same experience they would if you'd have put up 40 engines, you were trying to train them at a single location, making them doing away with the need to move about. So smart city isn't about what you see. Smart city is also about these higher levels of capabilities and intelligence that starts getting built into in the way we work and in the way we engage. So reducing traffic or reducing the need to travel is also a step towards making the city more livable and possibly smarter and greener. Next slide, please. Okay, so this is too much of detail. These are the key characteristics that I think everybody in this room must have seen many number of times. And the key bullet as far as the current talk is concerned is the last one, where you are talking about reduced end-to-end latency. You can move to the next slide. Okay. So these are the three things that I've already talked about. Massive machine type communications. Now this is to a degree the kind of devices that we were talking about in the previous session, but they do not provide very long distance coverage, but they do provide high degree of concurrency, which means up to 1 million nodes per square kilometer kind of connectivity. bullet that's of interest to us in this particular talk is the URLLC bullet, which talks about mission critical control. Now this is enabled one by ultra high availability and ultra low latency. And extreme mobility, of course, is a good option to have, but it's not that necessary. All the applications that we talk about, specifically haptics related, high availability and ultra low latency are the most important parameters as far as enabling these capabilities is concerned. And the third bullet, of course, is just better mobile sets. Next slide, please. All right, so this is the triangle that I talked about, and here let's look at the pointers around the vertices. So there's enhanced mobile broadband, where they talk of extreme data rates, they talk about deep awareness and extreme capacity. That is what this end of the triangle enables. As far as ultra reliable low latency is concerned, you want ultra low latency, you want a strong security, which I said will result implicitly, and the third thing is higher reliability, which is another thing that implicitly results while you try to enable ultra low latency. And then on the third vertex, you have this MMTC, where you're looking at high density, ultra low energy, and again you're looking at deep coverage. Next slide, please. Okay, then there's talk of spectrum, and this I will skip because this is for a lot of other people to discuss and debate. So we'll keep away from it. So we may, either of the two slides is fine. So then comes the last mile of the 5G air interface. Now, the talks in the previous session were primarily about the last mile. How do you make sure that the smart meters, for example, are connected to the rest of the network? So while the core improves with every generation, the air interface is what sees most of the action, and that's the one that becomes apparent to a lot of people. The tower sizes, the antennas that you see around you, the kind of handsets that you start carrying, the kind of devices that start getting supported. This is the part of the 5G or 4G or any generation technology that is most visible to the users. So the 5G air interface, of course, has improved in all fronts, in terms of concurrency, in terms of bandwidth, in terms of low latency. All of that has happened. But what we are interested in is that the connection from the user equipment to the base station will be buoyed or will be supported by another element known as the MEC, or the multi-access edge computing capability device. So what happens is that you, now we can move to the next slide because there's this diagram there. So here, as you see, now this is quite a busy diagram, and probably just talk about the key points that we see here. So you have a user equipment or some endpoint which connects to the network through the base station. Now the base station is in the newer implementations at quite a few locations will be supported by edge computing capability. And what edge computing capability will do for users is that it will help consume a lot of information at that level itself, so that quick decisions can be made. And the support onwards is only for those kind of activities which require careful inferencing. So you take that kind of non-real-time information back to the cloud and make stronger inferences. Hopefully, in the later slides, we might have an example of how this is being enabled. Can we move to the next slide, please? We might come back to this. Okay, we move on. We'll come back to this slide later. I just want to talk of an example. Can we move to the next slide here? Please go on. These are all good to have technologies. There'll be probably an example with. I'll talk about these. I don't need slides for these. So the previous slide. Right. So this is what I've been talking about. So you have user equipment, which is your user platform. Then you have your radio access network, which has a base station and a co-located MEC server. This is your MEC platform. And then finally, You have the core network where you have your cloud servers, and that is the cloud platform. So you could have wired communication taking you from the base station and MECs back towards the core, and you have wireless connection that connects you from the base station to the last mile. You have user equipment, which could be handsets, you could have vehicle mounted user equipment, you could have sensors as user equipment, you could also have high-end things such as the equipment needed for remote surgery as the endpoints. So this is what we're going to build on. The layer in the center is what is enabling some of the smart applications we're going to talk about. Yeah, so this is an introduction to tactile communication. So before I talk of a specific example to illustrate the strength that MECs bring to the table, let me say a couple of words about tactile communication. So tactile communication is about the sense of touch. It has two primary signals. One is a force signal, and the other is the sense of touch, which is texture. The first is called kinesthetic and the second is called tactile. The two together represent haptics as we know it. So this is being called tactile communication. There's also talk of tactile internet. So now what happens is, as people started moving from speech to video, what happened was that the need for higher bandwidth arose. When people moved from data, which is files, etc., to speech or video, need for real-time processing became necessary. But when you move to haptics, you you end up having two new needs. One is ultra low latency capability, and the second is high availability. To understand what this means is that if you do not, so a typical setup, or rather the simplest setup for a haptics application is a haptic glove, which is a device that is used to sense what the robotic hand or arm is doing and give signals to the robotic hand. At the remote end, you usually have a robotic hand mounted possibly on an arm or a moving platform, or whatever else you need to perform the task at hand. Now this hand is sensing the environment by its ability to sense touch, which means the texture of the object that it touches and the amount of force it needs to apply. Both of these represent the haptics feedback. This is usually supported by visual feedback as well. So you normally have a camera mounted on such devices so that the remote operator can feel what the robotic hand is feeling and also see what is around it. So what happens is, when this signal is fed back to the haptic glove, the person has to immediately tighten the grip or loosen the grip so that the robotic hand does not break the object or does not let it slip. Now this is an extremely time critical application. If there's a delay, then there's a potential possibility of the object falling, and a fragile object will break if it falls. So there is this need for very, very low latency, much lower than what we are used to as far as the other perceptions are concerned, which is speech and video. And the second thing is high availability. Even if you are guaranteeing low latency or ultra low latency for a very long time, but there's a brief break, and you keep on pressing on the object instead of stopping the amount of pressure you're putting in, again you could end up destroying the object rather than performing the task that you need to. So high availability and low latency are absolutely critical for tactile kind of applications. Now, even though we use tactile communication as sort of the vehicle, it can later be used for other applications as well. Can we move to the next slide, please? And here's an example of how mobile cloud does it. You want a end-to-end 1 millisecond latency delay. This is not possible if the signal from the robotic hand has to go all the way to the cloud server and then back to the haptic glove, and from the haptic glove actuation back to the robotic hand. So there will have to be edge computing devices installed so that this kind of inference is done at the base station level itself. So so whatever haptics information the robotic hand senses, it is quickly processed and transferred back to the haptic glove so that the human operator is able to make corrective actions. This is just the beginning. As the level of intelligence increases, what will happen is you will not need a remote human operator to perform the operation. That operator can be replaced by a set of algorithms. So on the one side, at the endpoint, you'll have a robo capable of performing dexterous manipulation, and on the other side, you'll have algorithms. So if you put one algorithm up, it will fill the shelves up. If you put another algorithm up, it will have the capability to pick stuff up from the floor and whatever else. So slowly, as you make it more and more intelligent and capable, you take the human operator out of the loop and potentially decrease the delay further, because there's only communication now needs to be done only from the hand to the edge and from the edge back to the hand. It does not have to go back all the way to the human operator, for example. So as tactile communication will evolve, we will see more and more algorithms being built to perform such tasks. This is similar to in a very oversimplified way, watching content live versus watching streamed content. We are used to watching both kinds. Today, if you have a human operator or a teleoperator doing the task, it's like watching something live, and streaming platforms have canned data. You can pick whatever you want to watch, and you can download it and watch it at your convenience. Next slide, please. So this is let this be the last slide. So here what we have is the setup that we have here at IIT Delhi. The way that we are doing this is that you have a haptic glove, which is the remote, which is the server end, and at the endpoint on the other hand, which is the left hand side, is the robotic hand. This robotic hand is the user equipment which is connected to a G-Node B. G-Node B has a co-located edge computing capability, and that edge computing capability, like I explained in the previous slides, helps make sure that the information reaches quickly to the haptic glove, so that the haptic glove can give the right actuations to the robotic hand. What you see on the top is another application which is possible in video surveillance, for example, or vehicle monitoring, for example. There could be two levels of surveillance. One is to make sure that a light has been jumped, and a slower analysis or inference could be which car has jumped the light. So these kind of things can also be enabled, and haptics is not just the only application that will enable it. So in the closing, what I want to say is that while 5G was about better mobile handsets, but it was about two more things. One, we talked about in the previous session. The other is the capability for low latency, high availability, and high privacy and security vis-a-vis things like edge computing, the ultra reliable low latency communication, part of which is enabled by edge computing. And this will enable a lot of future applications in smart cities. Thank you very much.
Yeah, thank you. And I think these slides have given the reply, like the long battery life of the devices, as in the case of machine type communication, as well as the URLLC, which will be mainly used for the vehicle to vehicle communication, as well as the remote surgery. Without taking much time, I would request Mr. Dharmendra Singh to kindly present.
So friends, so I'm from ESDS, and we have ESDS has 4 missions. One is connecting with 1 billion people, second is billion devices, 1 billion enterprises, and 1 billion trees. And if you see, these are the 4 applications from Atmanirbhar Bharat, which is deployed on our data centers, ESDS, and we will already achieve this target to connect with 1 billion people already.
and we are already connected with 1 million devices with 400 banking customers, 300 plus smart cities, and second largest IoT project is deployed by the ESDS, ATM machines, card transaction, and other connected to the cloud and POC devices. And we have 4 data centers in India. One is Nasik, second is Mumbai, and third and fourth is Bangalore and Mohali. And Noida, Chennai, Kolkata is on the way. And most soon we will going to launch this as soon as possible. And these are our data center compliances, which is tier 3, and all the data compliances which we have. And these are data and the patents which we have. And now we are also MITI compliant, and we are also delivering the government community cloud in terms of infrastructure as a service, platform as a service, disaster recovery, safe test environment, virtual VDI solutions, managed services, and other disaster recovery. ESDS are capable to deploy all those in their own data centers. And these are our server offerings which we have, which we are giving, like in our cloud hosting, we will already deliver SAP, HANA, government community cloud, smart cities, and enterprise community cloud, banking, BFSI, and public sector. We have expertise on data center, database administration, OS management, cloud enablement, and migrations from, it doesn't matter, it's from Azure or from AWS. If they are interested, we are capable to migrate from our ESDS cloud. And we are also in SOC services. After a few slides, I will also cover the SOC. And we have our these VDM scan and Inlight 360. Inlight 360, we have a vertical patent cloud computing on UK, US, and India, where we have a patent to vertically auto-scale the application. We no need to reboot the machine if you want to scale out. We on the fly, if you need more resources in terms of RAM and CPU, we can plug, you can increase, and we will have a capping kind of things. Once they will hit that kind of ratio threshold value, automatically they will be increased. And we have a VTM scan. VTM scan is for web-based application. If you want to check your web-based application vulnerabilities, we have this solution, and you can use that. It will give you the whole vulnerability report about your web-based application. And in our Inlight 360, okay, we will cover that. In Discom is our IoT-based power distribution, a complete solution, and give 360 degree of control for a smart grid initiatives. If with this Discom IoT-based system, it will easily integrate with the cloud services and the other application like network vulnerability, peak load, and power quality management, outage, fault management, network data mining, analysis, conditioning of network access and visualization, and network fault. We can easily integrate it with our cloud, and we will get the 360 degree of results on that. And yes, we have like we can also integrate with the transformers, tower, and meters. With this IoT, easily we can integrate with our cloud, and we will give you a solution on chatbot kind of thing. When the data comes from the different plants, machineries, meter devices, it will be quite tough to manage because they all are the unstructured data. So for that, we will use big data and analytics, which is used to simplify that data and will give you the visualization what all is going on your infra. And is also secure. Yes. And we have also done the smart metering project, which we will win approx 1 crore 25 lakh for this project, costing of this project. This is the architecture deployment method, which is HES, which is a application which is deployed on the meter side, and we will get those data and details in our MDMS platform. It's an application which is deployed on ESDS cloud. They are managed, and even you don't know, we have a petabyte of data which is managed by right now by ESDS for this smart meter deployment. And this is the architecture. We have a AMI system through which the data will be collected by the meter data management system, which is, I said, deployed on our side. And easily from that they will segregate and easily get the geographical information or customer care billing and the other things. Challenging and limitations which we will face, like integration with the existing system. For that we need to understand the deployment depth, data sovereignty security, data to reside within India, in community cloud system like I saw GCC, government community cloud, design requirement and architecture. For that we need in-depth analysis and architecture design. Last mile availability, option to select GPRS or RF mesh, because these two are technology by which we are able to they are going to push the data in our specific application which is deployed on our data centers. This one is our GCC cloud architecture, IoT layer, communication layer, which we have fiber optical and GPRS CDMA, and the rest of part is taken care by our application cloud and layer, where it is HES, MDM, report management, system management, and other mobile app is driven by our cloud. Now I'm talking about the SOC services. These are the three verticals which is managed by the ESG security services. For managed service security, I already said first is VTM scan. VTM scan is for web-based application to get the vulnerability of your application. Then we have an Inlight WAF, web-based application firewall. Inlight Web VPN, it's an agentless, not an agent-based. So it is easy to go without any agent. We have a EDR services, DLF services, endpoint backups, and these are the standalone services which anybody can go and use that. Antivirus, ZTNA, zero tolerance network architecture, and the email security. If you have kind of email security, like you have to gateway of the email, any spam mails you have to track, or we are working on, we can use this one. Otherwise, SOC services, Eagle Eye SOC services, security insight. In Eagle Eye SOC services, we will basically have a SOC in our data center. We have a SOC team. We are basically have a tools which we have to deploy. If you have a data center and you want us to give the SOC services, we will deploy some tools over there, and we will put some connectivity from your data centers to our SOC centers, and we will fetch and get those details with the other security like SIM. There is a tool which we have to deploy it in your system. They will get and give us the whole detail about what is going on, your infra and all. On that basis, we are give you the security on that. VAPT, vulnerability assessment and penetration testing, is also provided by our ESDS. And we are also give you the privilege access management services, which is there is one more tool which is developed by the ESDS, and which can use by anyone to use this privilege access management. These are our SaaS offerings provided by the ESDS. These are our cloud, what I said, Eagle Eye, the connectivity which we have to create in between your DMZ, means your data centers, and our SOC services. And after that, we will deploy some of the tools like SIM and other things into your data centers, and we will get the details, and we will continuously monitoring, give you the SOC services on that basis. These are our dashboards for the clear visibility. These are the power sector projects we have done, and our partners ESL, PFSI, Mahavitran, and all. Yes, Inlight 360 is our hybrid cloud. We are also providing public, private, and the hybrid cloud. We have already said we were patent with UK, US, and India for vertical autoscaling. If you have a data center and if you have a different kind of hypervisors, like if you have a different hypervisor, you have to manage that with the different management tools. So that's quite tough for everyone. If you have a VMware, if you have a Zen server. So within Inlight 360, you have to just deploy in your data center. It doesn't matter how many hypervisors you have. Through this single console, you are able to manage your whole data center, including application layer, including security, including any network topology, any protocol, everything with a single console you are able to manage through this Inlight 360. VTM scan already I have covered. Thank you. Done from my side.
Professor Rai, with your permission, I would just like to add that sometime back, TRAI had mandated TSTSI to come out with specifications, standards for cloud interoperability and portability. So TSTSI is working along with Cloud Computing Innovation Council of India for this activity. We have come out with a report which is published on our website on the cloud interoperability and portability framework across which covers information about what work is happening in this segment across the world. And we are now in the process of developing specifications for cloud interoperability piece. basically standardizing on APIs, etc. We hope to publish this standard in the coming year. If anybody is interested in engaging with TSTSI in this activity, you can reach out to the TSTSI Secretariat. You can reach out to me and we'll be very happy to onboard you for this particular activity. Thank you.
Thank you for that update, Sindhu, and thank you, Dharmendra, for that enlightening talk. And now we move on to the next speaker. The next speaker is going to join us online, and the speaker is Bhargav Thakur. He is the head of NDP Smart Utility Vodafone Idea, and he is going to talk to us about role of TSPs in accelerating digitization of utility value chain. So if we can get him to connect and enlighten us.
Yeah, hi, Ms.
Hello.
Yeah. Great. Would you like me
I am just sharing my screen.
Yeah.
Do let me know once you can see my screen.
Yes.
Okay, great. So good evening one and all. My name is Bhargav Thakur. I am heading the new products development department for IoT for smart utilities vertical within Vodafone Idea, IoT line of business. I am here to today talk about the role of TSP in accelerating digitalization within utilities, within which the overall agenda which I'm going to talk about today is, the AMI journey or smart metering journey over the years from a TSP perspective to our experiences, Vodafone being part of such projects, what are other experiences, insights, to what does IoT connectivity mean truly in terms of is it just a deployment of SIMs within the smart meters or it is much more than that? And then what different roles can be played by TSPs in smart metering, the cornerstones or the enablers with respect to that, which will eventually help in accelerating the digitalization. So before moving forward, I hope there is no lag here and you are able to see the screen. So we are the #1 rated IoT service provider in the country, which is as per the report of industry analyst FNS in FY22. We have, the first in the country IoT lab, which we have actually derived or which is with the association with a CDOT entity from the government, which is the Department of Telematics, right? So it is a center of development for Department of Telematics. Talking about smart metering with relevant to that, we are the market leaders where 2 in every 3 smart meters in the country are being powered by VI IoT M2M solution. Similarly, we have other businesses also from connected car to mobility to POS and everything. So overall, I would say we are more than happy to say that we already cater or we have onboarded more than 130 million endpoints or enterprise IoT connections onto our network. Moving on, the AMI journey from a TSP's perspective, let's go back a little and from the historic or timeline perspective, let's see how the evolution has taken place in terms of technologies or roadmaps in the telecom sector as well as in the electric sector, especially the distribution or in the metrology, right? So considering that as a timeline, 1996 to early 2000s, right? The 2G services were enabled or rolled out by the telecom service providers, whereas it was more based on PD, MA, CST or a circuit switch network based approach. Where just to give you an example, we used to have facsimile systems, fax services, right, in every offices, which used to basically work on a dedicated sessions end to end, and then the data transfer used to happen. So that was one of the first steps, or as I would like to call it, phase 1 in terms of data transfer from the feed to the server. Next came 2.5G with the enhancement of Edge or GPRS, General Packet Radio Services, HSPA, etc. The capacity and the bandwidth offered by telecom service providers basically got enhanced, and that allowed IP-based communication as well, where predominantly IPv4-based technology was used for pushing data right from the field to the servers, as we call it as a MDAS system, meter data acquisition system, at the control center. And a lot of trials in the area of AMR, automated meter reading, as we used to call it, under the scheme of RAPD, and all had happened, where few thousand or up to a lakh of meters were pushing data to the central location. But again, here the evolution had happened in its own manner. So metering was following one route, as well as the telecom was following the another route. Then around 2010 or 2000 till 2015-16, 3G services were rolled out, where we had seen around that time the AMI pilots, smart grid pilots had taken place, as well as the communication technologies and the requirements also got enhanced, where now the experiences or the learnings which were there from the earlier deployments cater to the new requirements, which was IPv6 with a bidirectional communication, prepaid metering, remote connect, disconnect, alert. So all these basically requirements were constituents to a low latency and a continuous data communication that is a very high availability. And then basically came 4G, and now we are also talking about 5G, where we are seeing a mass deployment of or a rollout of a smart metering tenders across the country, pan India, right? Now, a point which I would like to highlight here is that individually, the meteorology had its own evolution, as well as telecom was rolling out the newer technologies in its own pace as per its own roadmap. Just to highlight one point, like for example, when 4G got launched around 2017, then that time 3G became a little redundant for that. And to continue with that sort of services, the decision was taken from the industry perspective that it is easier to promote and enhance the coverage through 4G rather than retaining the 5G services, which actually led to few of the investments going for a toss from the hardware perspective, specifically in the area of advanced metering infrastructure. So, I mean, these are kind of the gaps which had happened because of this roadmap, which was not in a very collaborative manner. So the collaboration of the TSP, or I would say the role of TSP, was very limited, was on an ad hoc basis and on a requirement basis as per the industry requirement or project requirement. Where moving forward, what we feel is that it has to be a collaborative approach. The important stakeholders, right from the Ministry of Power to the policymakers, including then the telecom service providers or TSPs like ourselves, we need to come together and we need to collaborate in terms of defining the roadmap and the evolution together in terms of the telecom roadmap as well in terms of newer technologies, so that it is sacrosanct and catering to the need of the hour of metering evolution. Like the mandate what we have today of implementing 25 crore smart meters, moving from postpaid to prepaid for all commercial and residential customers. That brings us to the next slide, that is the VI experiences and insights. From the experience perspective, Vodafone Group or Vodafone as a brand is a well-known company in the area of utility or power industry, where the company has been associated with more than 90 plus discoms across the world. In India, talking about the local country and the market, VI is a leading solution provider for AMI or AMR, where we, in the past decade or more than that, where we have actually onboarded more than 3 million endpoints or meters onto our network, and we are collaborating directly or indirectly with more than 18 plus discoms across the country. From the coverage perspective, we have 1.2 billion population coverage, 3 lakh plus 5 kilometer fiber, and we are covering almost more than 5 lakh plus towns and villages, right? These are some of the discoms or the logos which we have acquired in the past and the present, and we are catering to the different kinds of services or requirements from these particular customers. Now, with this experience came, we came across different challenges which we overcome in catering and satisfying our customers' requirements and needs, but it also gave us a lot of learning. which we would like to bring out in the kind of an insights with the forum over here, right? Like for example, a bidirectional call flow with an IPv6 private static IPv6 is a requirement which was a requirement from, I would say, deploying a multi-million endpoint. A static IPv6 kind of a requirement for a telecom network is not a showstopper, but a big thing from the rollout perspective, which was one of the initial learnings when we participated in such projects as a telecom service provider. One other learning which came out of this project is that meters are being installed in areas where there are coverages which are very low or lower than minus 100 dBm as well. From the requirement perspective, the customer today in the AMI projects or smart metering rollout expects that there is a near real-time connection, disconnection of the consumers absolutely, and the load data or the data from the consumer also has to be updated near real time. There is a requirement from the customers who specifically, different stakeholders in the fraternity, they do ask that do you have a cellular NMS or an NMS for a cellular sort of a network. Then came the concurrency of the meter data communication over the network, over 4G or over 2G, depends along with the OTA and FOTA, which is needed. So these are different experiences and insights which came out of, by participating in such projects, which actually led us and taught us that IoT or M2M connectivity is not just about supplying the SIMs or deploying the SIMs, it's much more than that, right? There are too much of parameters or variables associated with which we need to look at and consider before deploying such a mass rollout. Some of the important points which we felt we have listed down on the slide, starting with the network coverage, feasibility and planning. Just to highlight from the coverage perspective, in every smart metering rollout project or a tender, a master system integrator or a AMI SP as we say, is supposed to do a consumer indexing, right? Now this consumer indexing can also have a very vital and important activity associated with that, because the team or the system integrator is supposed to go to all the consumers on the field from the GPS location or coordinates perspective, so that wherever the meters are getting installed, a network feasibility testing or a coverage analysis can be done through a simple application in the mobile phones, where the coverage of the 4G or 2G can be analyzed in terms of a DBM and can be recorded at the time of consumer recording. So this consumer indexing, sorry. So I mean, these are the kind of learnings or recommendations which we have come up with over time, where we feel it is not only about connectivity. Next is about the usage of a plastic SIM card, which usually you use in your mobile devices, but you see that these devices are we basically use those SIMs for a couple of years, that is 4 to 5 years maximum, and then we have to change that SIM out of the necessity or out of the wear and tear. Similarly, those same SIM cards cannot be used or should not be used in this projects, because there will be a direct or indirect cost associated with it. So we always advocate or recommend that robust plastic SIM or industrial SIM could be used in such projects, as these are long tenure projects of 8 to 10 years, right? Another important cornerstone is that the visibility of the connectivity, that is the SIM cards which are being deployed on the field, also needs to be visible to the customer in terms of its status, whether it is active, it is in ready state, it is suspended, etc. and all that, which basically comes out from a connectivity management platform, which is it is an IoT platform for the management of the SIMs, which is provided by Vodafone Idea. Another important aspect is the cellular NMS, which basically we address through our device management system, where we collaborate with the hardware providers in the industry, right? And there are two kinds of hardware which are basically going into the meters. So what really makes a meter smart is actually the communication capability of that meter. Metering has been happening right from electrical, electromechanical to electric meters. It has its own journey, but what truly made those smart meters smart is the communication capability of it, which happens through a modem or a NIC card as we call it, right? It could be based on a 4G fallback to 2G sort of a modem or a NIC card, or an RF based communication technology. But NMS plays a very vital role in terms of the discovery fault management, visibility, SLA management, etc. aspects from the deployment and cost perspective in the O&M phase of the project. Similarly, all these meters which are smart, they actually hop onto the network at times, and the hardware and the software logic or the firmware which has been written, which also needs to be tested, because many of the times, the devices are trying to hawk the network, which is nothing but in a layman's term, or in a technical term rather, I would say, would kind of sound like a DDoS attack, because there are concurrently lakhs of meters which are trying to hop onto the network, right? So basically, to avoid such confusions or issues, what we do is basically we test those meters for interoperability from the network or connectivity perspective in our IoT lab, which basically concurrently, I would say, this constitutes to the entire transparency in terms of SLAs and SLA management, because in all such projects, as we know, the SLAs are associated with their respective penalties also. Now, why this is important is because even though a TSP has a limited role in the project, where they might be, from the cost composition perspective, hardly 15 to 20% of an overall AMI project, if there is no proper collaboration with the TSP, then it can lead to more than 50% of the overall operational issues on the field when you are rolling out such a project. So these are the kind of learnings which we have seen being as a part of projects like EESL also, where we are the telecom service providers. Next, that brings me to the next slide, that what all roles can a TSP play in the smart metering? How can we contribute? So I would like to pause here for a second and to give you a perspective from a telecom service provider perspective, that we are in ourselves acting as a utility for our customers, where we are managing the data connectivity billings of millions of prepaid and postpaid customers on a real-time basis. And we have the experience, from the scalability and complexity perspective to handle such a larger project. And then that actually gives us confidence to say that, are we only limited to the telecom or the connectivity piece of it, or can we play a larger role over here? So some of the high level points from the perspective of what roles a TSP can cater to is from network coverage, where we provide a coverage across pan India, a 4G, 2G, or depending on the region, even 3G services as well. And the network, what is there, which has been deployed for mobility customers, is utilized for IoT or M2M use cases like electric smart metering or AMI as well. So the deployment or the rollout of the project will be much faster, and the network in terms of coverage and all is much more flexible or elastic as well, which can be very closely coordinated from the project perspective. A TSP can bring, with our IoT lab testing and all, we basically can bring an end-to-end visibility to, from the meter and its NIC card perspective, where we have done the testing, we are able to connect remotely with that particular meter and do the device management through our IoT platform. So that basically gives you an end-to-end visibility right from the network perspective or a HES application perspective, where the meter reads are being registered, till the meter hardware on the field. This eventually helps you basically in doing the proactive SLA management, where basically in such projects, master system integrator or a DISCOM, eventually will spend a lot of money or there will be a losses in terms of if the SLAs are not met, right? So that's where TSPs can basically help proactively doing the triaging and root cause analysis for the SLA management. Last but not the least and important aspect is that TSPs has the capability and resources, and the strength to enter into such long-term contracts of 8 to 10 years when we talk about the smart metering. Moving on, so to enable the industry, there are some steps necessary which we have taken, to enable the industry for a faster rollout and adaptation or digitization across utilities. For example, in AMI, where we have basically come up with an IoT lab in joint certification with CDOT, right? As I mentioned earlier also, where this is going as a lab as a service model. Now the requirement of it comes because the ecosystem today, as we speak, also is still fragmented. there could be some unplanned cost or issues which are coming up because of the hardware issues or the firmware issues on the field, interoperability, compatibility, and the lack of compliance to the standards. This issues basically result in the slower adoption or rollout of such IoT projects or smart metering projects. So what we have done is, along with CDOT, we have identified the use cases from the network perspective to the for different kinds of hardwares in the entire ecosystem, where we do the network related testing for different use cases. We are agnostic to technology. We test it across different technologies. We are ourselves a one M2M, or I would say M2M service provider, and we advocate that the developments what are taking place in terms of hardware and software, they are in line with one M2M, 3GPP, GSMA, etc. So this is one of the cornerstones which we feel will be an ecosystem orchestrator from our perspective, where the majority of the operational issues or faster deployment issues faced in faster deployment will be ruled out once we have gone through the route of testing through an IoT lab like this. Which brings me to the business alignment of VIs, where VI has basically created an offering. Our strategy and offering around, I would say, in the space of smart metering or AMI is that you have smart meters on the field who are connecting through 4G or 2G network with a backhaul of MPLS, and then there is a cloud-based HES and an MDM software, where wants to play a larger role, or we feel a TSP can play a larger role here, where we ensure that the data from the hardware on the field is brought to the application hosted on the cloud. The reason we basically feel that this is a role which a telecom player like VI can play is because today also whatever communication, the voice, the data through voice services, data services, etc. is comes to our mediation system, which is a middle layer system, and then goes to our billing system, etc., based on which we do the customer billing and etc. And that's where we feel that competence of the existing mechanism or a structure of the organization as a TSP will be able to help you do the end-to-end SLA management, as we will have the end-to-end visibility of why the data is not reaching onto the platform. So what can we do in accelerating the digitalization? This is my last slide, so I'm almost done. Yeah. So the immediate actionable in accelerating the digitalization, what we see is the testing of the hardware with the TSPs for interoperability and all the test cases. The connectivity methods, whether you talk about a cellular or a RF based, that needs to be adjusted based on the project or case-to-case basis and a geography. Network coverage, feasibility, which I already talked about, and there has to be a deep integration between the IT systems of the TSPs as well as of the AMI systems like HES or an MDM. So these are some of the immediate activities which we can take upon and help in accelerating digitalization in this particular space. Long-term actionable, I would say there has to be a cross-working group from the different representative or stakeholders, right from MOP, TSDSI, IMA, TEC, etc., who along with the TSP can help us define the connectivity roadmap, interoperability, standardization in terms of hardware of one M2M. And another important part is we always talk about data transfer using the data services, but SMS is a very persistent mechanism, a good mechanism which we have, which can also be used for remote connectivity, testing, troubleshooting, RCDC, etc. So which needs to be or could be included in the IS 15959 standard as well. So these are some of the thoughts which we will leave you with, which in our experience we see that is very important in terms of accelerating the digitalization as well as adoption of newer technologies. Thank you. If there are any questions, I can take those. Otherwise, thank you so much for this time.
Yeah, thank you. So we take questions now. Yeah. Okay.
Yes, sir. May I audible, sir? Hello.
Hello.
Mrs.
Mr.
Thakur?
Yeah. Mr. Bhargav, are you able to hear us?
Hello.
Yeah, Shefali, I'm still here. Yeah,
Okay.
I'm here.
Yeah. Yeah. So there's a question.
Well, let me introduce myself, Sanjay Verma. I am from Madhya Gujarat Beach Company Limited, your client. Actually,
Yes, sir.
we have installed the AMR meters in MGBCL. We are having 7 districts. As you told that the data is being communicated, but we are facing the connectivity issues. So what is the main reason for that, sir?
So, I mean, I would just take you back to the, okay, I've stopped presenting. So, I mean, the issues in terms of connectivity, a lot of times, it actually, happens that people feel that network is not visible, right? So today, what we understand is if data is not coming onto the platform, then it is an issue basically persisting with the network. But many of the time it is not the case. 90% of the time what we have understood is that there are challenges on the hardware side as well, and when I say hardware, it's not the metering hardware. What we have seen is proactively is through our testing and findings is the NIC card or the communication module which is being used within the meter to make it a smart meter. So it could be the possibility is that there primarily I will acknowledge or concede one point is that there could be genuinely a connectivity issue where the coverage could be an issue. So that can be done through a site survey on what dB level signal is being coming across the deployments. Second is on the hardware side with an integrated testing with a firmware logic what it has been written on the meters or the NIC cards because it has a separate firmware running in the background for the NIC card as well. So that's why the hardware is another important aspect. I would say from the interoperability and integration testing. So if I would say genuinely you're facing an issue, do take my contact details from Shefali or other, and we can connect offline to discuss on what type of hardware is being deployed and how we can help you resolve that issue.
Sir, actually we have replaced the modem also, and then even though we are not getting the data, and then we have replaced the SIM to Geo, then we are able to get the data. Even in Baroda city, we are also not getting the 4G data in some of the pockets. Even in city area, we are not even communicate or run our internet in our mobile. So I think this is the connectivity issue, sir.
Okay, I hear you. So see, I mean, from your explanation, it seems like a genuine network coverage issue in the vicinity. So this definitely, we would love to take it offline to help you resolve the issues what you're facing right now.
So several times
for the existing installation.
several times we have talked with your local teams, but unfortunately the issue is not being resolved. Now we are switching to the RDSS and smart metering, so it will be very difficult for us to proceed further. Thank you, sir.
Oh, sorry for the inconvenience, sir.
Good evening, Mr. Bhargav. I'm Nitin Marjara from Tata Power. I have a specific question that whenever we feel these communication issues, we are always stuck up between different service providers or the OEMs that they keep on saying that problem is on the other side. So we need to have, as a user, as an electrical engineer, not as a communication engineer, I need to have a system with which I can trace the system that from exactly where the data is moving and where it is getting struck. As of now, if I have to do this testing, I have to engage my IT team, user team, meter OEM, HES OEM, MDM OEM. All of them have to come together and sit and then do this analysis. So are you developing any such software where we can see that whether the data is coming up to your network and is passed on to further HES or not? So this is something which is required to make it more transparent to identify exactly where the problem is.
Okay, I didn't get the name, but I could understand the question, so I'll try to answer that question. So basically, sir, the issues what you have highlighted today are the issues being faced by DISCOMs, the AMI, SP or master system integrators on the field. Because today, if we see from the contractual perspective of aspect of the project, the AMISP or a master system integrator is dealing separately with the telecom service provider, for the cloud services separately, HES separately, and everybody is working in silos. Because even though the AMISP today is governed by the SLAs for the meter reads on HES platform or MDM, right? But individual OEMs or service providers are basically able to cater SLAs with respect to the scope of work what they are trying to do. And this is the shackle which we are trying to break with at Vodafone Idea. So if you see the important block in the middle, what we are trying to address with our offering and a strategy of integrated IoT is that we are providing connectivity, cloud and HES platform, as well as we are doing the hardware integration testing also through our IoT lab. So what happens is in terms of a rollout, we are taking the end-to-end ownership of SLA meter reads. Okay, because today what happens if, let's say for example, in a project, a MSI comes to me who has taken a SIM card from me or just the connectivity and is asking about the meter reads, as a telco, I do not have the visibility on the hardware as well as on the cloud or HES platform, whether the genuinely meter reads are coming or not, right? Then by becoming this system integrator, by doing this particular scope of work, we are ready to take that ownership and we are ready to do that system integration from the HES perspective with our IT systems like connectivity management platform, device management platform. That deep system integration definitely will give you that enhanced visibility of the hardware on the field, the network, the SIM card associated with that, as well as the meter reads on the HES platform. So this basically is an overall strategy which is revolved around breaking that problem, because the problem what we have highlighted today is not a local problem but a global problem which discoms are facing across the world. So we sincerely believe that with this kind of an approach, we will be able to address those issues. I hope that answers your question.
No, there is again a concern. You are saying that take my product and it will work. So it cannot be like Vodafone products can be put everywhere, because it's, you understand the utility perspective. We are in a regulatory framework. We have to go by open tendering, and anyone who is L1 has to come, and of course complying with the technical specification. In my case, we are AMI SP by our own. We are having this HES and MDM housed in our own data center, and we have experts working over there. But then we need to have a visibility in the network that yes, the data is getting latched to the network or the SIM is getting latched to the network. We want that facility at my desktop. And then I can see whether it is then coming to my MDM or not. I don't want to get dependent upon the communication team of mine, because they are busy in their own activities day in, day out. As a AMI engineer working on deploying the meters and ensuring connectivity, this flexibility I need in the system.
I do agree with you, and in present role also, we are doing it in EESL project where we are, sharing that info or insight from the connectivity perspective, whether from the SIM perspective, I would say, on its state of active, inactive, suspended, etc. and all through our connectivity management platform. And from the hardware perspective, we are trying to address it with a DMS, that is the device management system, which basically will eventually become a cellular NMS for our customers for the cellular rollout part. So we are trying to bridge that gap with these two particular platforms, and that is one of the recommendation of deep IT system integration with the HES or an MDM of both these IoT platforms.
So how long will you take to develop this NMS?
Sorry, come again?
How long will you take to develop this NMS? Because this is the burning issue and this is the pain area.
Yeah. So as we talk about this, this is a part or a subsidiary of a connectivity management platform which is already developed, and the deployment, or I would say the relevance of the same will increase once basically we have integrated with the NIC cards or modems which are going into the smart meters. So where we are associating with the meter manufacturers also, bringing those hardware into our IoT lab and doing the deep integration on the hardware part. So that has already started, but yeah, it will take, I would say, some time for us to onboard them onto our device management system. I will be more than happy to answer other questions from you, sir, offline if we need it.
This is Bindu. May I add here that some of these problems that have been pointed out have been have been there for quite some time. DOT has come out with an initiative called 5G use case labs, and we would encourage the concerned stakeholders to probably reach out to Alex to see how such problems can be investigated in a lab setup to start with through the 5G use case labs initiative, and then maybe pilots can be conducted in the field through the two utilities that are there in the room. And the fact that the NMS is being developed by Vodafone Idea along with in partnership with CDOT, maybe the utilities can be invited to have a closer offline interaction with the team. And through TSTSI, there is, in fact, the next, may I steal the thunder? The next speaker, Rajesh Kapoorji, will be talking about communication requirements in the energy sector, where a study is being conducted in TSTSI on some such issues. So probably some of the utilities could join us in TSTSI to point out these problems, these specific problems, and the TSTSI members, all the TSPs are TSTSI members. We have MVNOs also. Maybe we could collectively come out with some standardized ways of analyzing the health of the communication. So may I, Professor Lal, invite Mr. Rajesh Kapoor to please present. Mr. Kapoor, over to you.
Am I audible?
Yes, sir.
I'll share my screen. I hope my screen is visible to all.
Yes, sir.
Is the screen visible?
Yes, sir.
Thank you. So, good evening to all. I am Rajesh Kapoor. I am consultant with TSDSI. TSDSI, as you are aware, everybody is aware, it is a standards development body of India, and it is a members-driven organization. And TSDSI is a partner of the global standard organizations like 3GPP, 1M2M. It is a sector member of ITUT and ITUR also. And communication requirements of the energy sector is an active subject in the global bodies as well. And TSDSI has also a study item SI87 on the subject as well. And this has come out as an initiation from the members themselves. And the background I'll give about this particular study item, that a proposal for the study was initiated in
Kapoor,
TSD.
can I ask you to make this in screen share mode, sorry, the slideshow mode?
Okay. So, NSGM gave a presentation detailing the problems, issues, and challenges in June 2022. They gave details about their smart metering infrastructure, the architecture they are having, the network operations, and the challenges being faced by them. And these issues and challenges were discussed in our technical plenary in September 2022. And Reliance CGO offered to co-champion the study along with NSDM. And study was introduced in December 2022 plenary to discuss the current data available from NSGM and provide a holistic recommendation to NSGM. So NSGM, as part of their presentation, gave this particular diagram that there is a metering infrastructure where there is a data concentrator unit, and a backhaul is there for transferring their meter data to the control center, and the entire process of energy metering and the various applications that is happening on the network. And the infrastructure which this is another slide which they gave about the uplink of the data from the meters and the downlink side also, where they connect to the meters and retrieve the data from the meters. The volume they have indicated 250 million meters, and per quarter they have 0.5 million of meters that are being processed. So the areas which they are looking at is the urban areas, semi-urban areas, and rural areas where they want these services to happen in a fault-free manner, and the efficiencies they are achieved. Beyond that, they talked about the various applications of the power sector, like advanced metering infrastructure, AMI network management, automated feeder switches, capacitor bank control, charging, plug-in electric vehicle, demand response, direct load control, distributed generation, distributed assets management, emergency response, fault current indicator, in-home meter data management, bandwidth requirement, reliability and latency requirements for the various applications. I'm getting can it be muted? Can you be muted? Issues and challenges were raised by the issues and challenges were raised by NSGM in respect of the performance of cellular communication infrastructure between the smart meters and head-end system.
Ankita, can you please mute yourself?
Yes, Ankita, can you please mute yourself? Ankita, can you please mute yourself on the
so performance on the cellular network, they pointed out on the smart meter and head-end side on the GPRS system, which is not satisfactory. Communication rate is not up to desired level for daily reads, and reliability of the data fluctuates due to network tuning issues. Communication rate as of now, June 2021, is 90 to 92% for cellular technologies and 98% for RF mesh-based communications. Disconnection and reconnection of meters, which is very time critical, also raises performance issues. 8% of the devices fail to disconnect and reconnect as on June 2021. Reliability of the data hovers 80% as of June 2021 and is seen especially in urban areas, suburban areas due to the network tuning issues. Interoperability issues they raised, that interoperability between the network information card and smart meters, and interoperability between the smart meters and the head end, high initial costing of the smart meters, security related issues, possible denial of service attacks, targeting servers with computationally intensive requests, transport layer with the traffic flooding, worm propagation attacks, MAC level with spoofing, target availability, physical layer with RF jamming, cloud interoperability issues like challenges in moving from physical to cloud data centers, interoperability of cloud with reference to data and services, migration and balancing, key players readiness and issues, use cases for cloud interoperability and portability, recommendations way forward for power sector smart grid. So these were the issues and challenges which were raised by NSGM in their presentation to the TSDSI members. And the study item was initiated SI 87, where the study group includes IIT Hyderabad, Reliance Jio, CDAC, NSDM, TCS, IIT Delhi. They are actively participating in the group discussions on the subject matter of issues, challenges, and how to go about. And existing specifications of BIS 16444, overall requirements of AMI, and specification 15959 regarding hardware software requirement. They have also been deliberated. The discussions have identified that the message and content sending over the network is of higher size. That means there is a scope of optimization of the data packets also, and the frequency of company Hyderabad and Reliance Jio are doing a optimization activity at IIT Hyderabad, and the results of that study will also be available in the study group for the next course of action. So this is how the study item is being progressed in TSDSI regarding the smart metering and applications of power sector. And since this encourage that more and more members should participate in the study group SI 87, so that we have a very foolproof standard method which is available, and all the participants of the vendors and the service providers, they are able to collaborate and give such a solution which is able to bring the issues and challenges of NSGM sorted out, and a global harmony is available, and the members can take forward these contributions from here onto the global bodies in ITUT also and 3GPP also. So this is all from my side. Thank you. If there are any questions, I'll take it up. Thank you.
So with that, we come to the end of the session. And it back to Bindu.
Thank you very much, Professor Lal. That brings us to the end of this particular session, where we covered a range of topics around communication systems for the energy sector. One thing that we missed in the entire 3 hours today was the power sector. By virtue of the electrical lines going right up to the home, there is a possibility of extending 5G services through, in partnership with the electricity utility sector going forward. I believe some such experiments are already going on, and street light furniture, etc., is already being considered. But this has a potential which probably we can take up in the next edition of ISUW. Thank you very much for staying with us in this particular session. For any follow-on questions or engagement with TSDSI on the activities being carried out, please feel free to reach out to us to me. My contact is given in the brochure. Thank you very much. May I also, and before we conclude finally, May I request Mr. Sanjeev Rana to please felicitate the speakers at on the dais. Professor Lal, come forward. Or you won't go up? Yeah. And perhaps IIT Delhi and Tata Power can consider how MEC, multi-axis edge computing and haptics can be considered for drone-based O&M services in the transmission lines. And thank you very much for felicitating the. Thank you. Shipali, please come.